Hello, I'm Sterling Burnett, Senior Fellow and Managing Editor of Environment and Climate News with the Heartland Institute. I'm pleased to be here with you today for the 6th presentation in our 14th International Conference on Climate Change lecture series. I thank everyone out there who is joining us. The date for the 14th International Conference on Climate Change is not far off. Anyone who wants to attend the event at Caesars Palace in Las Vegas, Nevada, running from October 15th through 17th, better make their arrangements quick. I really encourage you to contact Heartland's office to get answers to any unanswered questions you might have after viewing our website and to make or confirm registration and planned attendance. The conference's theme, The Great Reset, Climate Realism versus Climate Socialism, and it speaks to our times. As with our previous conferences, we will have a stellar lineup of researchers on hand to explore the science, economics, and policy issues surrounding climate change. This lecture series presents brief previews of coming events from the conference's top speakers. I'm pleased to have today speaker, longtime friend, and preeminent award-winning climate scientist Pat Michaels, who serves as Senior Fellow at the Competitive Enterprise Institute. In addition to having previously served as the State Climatologist for the Commonwealth of Virginia and as President of the American Association of State Climatologists, Pat has authored or co-authored dozens of peer-reviewed papers and several books exploring climate science and how it is communicated, or more appropriately, miscommunicated. Pat always is an engaging speaker, so I'm sure you'll enjoy his presentation and have many questions at the end. His topic is the vast discrepancy between climate reality and climate model projections. I want to say, if anyone has questions, please send them via the comments function on the program, right-hand side of your screen. We will have 10 to 15 minutes to answer questions at the end of Michael's talks. Pat, thanks for being with us. Take it away.
Great to be here, Sterling, and nice to be invited to talk about what's going on in the world of climate. I think we can start with my title slide here, which is Climate Models versus Reality. The title is designed, of course, to bring forth a lot of questions. Let me summarize what I am going to talk about, which is in the next image. Okay. There are three main topics I want to hit. First of all, models have the wrong input. In other words, they are fed scenarios for changing concentrations of atmospheric greenhouse gases and other things that are known to be wrong and have been known to be wrong for several years now. All the impacts research that we read about, the effects on agriculture, the effects on construction industry, whatever, if they have the wrong input, the output is simply not trustworthy. Number two, because they have the wrong input and because they have inherent shortcomings which have nothing to do with the input, but rather with the internal workings of these large computer models, they run far too hot. They're predicting much more warming than is occurring now, has occurred in recent decades, or will occur in coming decades. And what we are left with instead is a world that's not going to warm up that much. Yes, it will warm some, but is certainly getting greener. At the end of this talk, we will examine humans' role in making the planet a greener place. And I think the data is actually just pretty much stunning and breathtaking. So let's take a look at this problem with the model input. The quote here is from Zeke Hausfather and Greg Peters in Nature magazine in 2020. Now, remember, Nature and its counterpart in the United States, Science magazine, are way off to the left on this issue, I guess because that's what sells copy. And so they don't print very many articles that attack what the consensus is that they already generated. But here in Nature magazine last year, Zeke Hausfather, who is hardly a climate skeptic, and nor am I a climate skeptic, there is climate and it changes. But the first sentence in the article were words that were very strong for Nature magazine. Quote, "Stop using the worst case scenario for climate warming as the most likely outcome. More realistic baselines make for better policy." What that statement says is we are using unrealistic input into the models, and therefore we are making bad policy. Now, the inputs are mathematical definitions of the increasing amount of warming energy down to the surface of the Earth that occurs when you put carbon dioxide, and other greenhouse gases, and other things into the atmosphere. To give you an idea, it's expressed as watts per meter squared. So, old incandescent Christmas tree bulb might be about 10 watts per meter squared or something like that. Well, the change in the worst case scenario is 8.5 watts per meter squared. They're called RCPs, or representative concentration pathways. And RCP 8.5 is the one that assumes that there's no adaptation, that there's no policy whatsoever. Well, that's crazy. All you have to do is look at what's happened in the Great Plains, where we're fracking natural gas so much so that we became energy independent during the last administration, net exporter of energy. That replaces coal, which produces a lot more carbon dioxide when you use it to produce electricity. So that's one thing we're doing. We're just not on that pathway. Now, in the House Father article, there's an illustration, which is going to be a little bit hard to follow, but I'm going to put it up anyway. These are the various representative concentration pathways. The one that is going way up there on the top of the chart is the RCP 8.5 watts per meter squared, which the authors label in bold as highly unlikely, often wrongly cited as business as usual. The likely ones, which are two further down, are between RCP 4 and RCP 6.0. And you can see the emissions growth in these is much less than is in RCP 8.5. So let's go over to the next image, if we could, and take a look at what's happened. I said the models are running too hot and they have the wrong input. This chart was first put out in 2017 by John Christie from the University of Alabama at Huntsville. He is the guy, along with Roy Spencer, who developed the satellite temperature history. They published the first paper on that in 1990, and it showed no warming whatsoever in the 1980s, and everybody's jaw kind of dropped. I didn't. Mine did not. I knew there were problems with those surface temperature measurements. Anyway, each thin piece of colored spaghetti on this chart is a climate model. And if you look on the left side of the chart, those are all the acronyms for the various climate models and the legends for their colors on this chart. The solid red line is the average of all these models. This is called the Coupled Model Intercomparison Project, fifth evolution of it. So it's CMIP-5. These are the models that were valid when this chart was made. It is in the process of being replaced by CMIP-6, which will be used in the upcoming United Nations report on climate change, which should be out by the time we all are in Las Vegas, by the way. And on the bottom of the chart, the solid figures are the average of the satellite measured temperatures, the average of the weather balloon measured temperatures, and something called the reanalysis data, which is cleaned up observational data that goes into the daily weather forecast. And you can see that these just aren't warming up at anything close to the rate predicted by the models. Now, one thing, if you're looking very carefully, there's one piece of colored spaghetti that actually goes through the observed data. This, by the way, is for the tropics, and I'll explain why the tropics are so important in the next image, but let's stay on this image for a second. If we were doing what I would call the proper scientific way of developing a forecast, you don't take all the models and take their average and their variability and say, that's the forecast. No, it's not. In the daily weather forecast, for example, forecasters have many, many models, global models and regional models to choose from. They don't average them all up. They look and see which model or which models have been working very well recently, or maybe work very well in what the current forecast problem is. Maybe it's an East Coast snowstorm or something like that. Maybe it's then hurricane, then tropical storm, then post-tropical storm Sandy, which was forecast extremely well by one model, the European model. People recognized that was a better model, and they used it, and they got the forecast right. If they had averaged all the forecasts together, Sandy was not supposed to hit land. And that's a great deal of difference in outcomes. So you can really make huge mistakes by averaging up the models rather than using the one or ones that work. Now, on the next chart, this is the second most complicated chart in this somewhat boring talk, but be relieved that it's the second most. We're going to take a look at the behavior of climate in the vertical over the tropics. Oh no, I'm sorry. That's 2 slides from now. The next slide is the one that shows the new improved CMIP-6 coupled model intercomparison 6 climate models compared to reality. And what you see, there you go. The colored spaghetti now, those are the new and improved models. This is again for the upper troposphere, which turns out to be very important. I'll discuss that in a second. And the green solid line are the observations. And again, you can see the disparity between the two is actually greater than it was in the previous chart. In fact, the new CMIP-6 models are warmer in general than the previous generation of CMIP-5 models. That's mind-boggling. The more money taxpayers throw at this problem, the worse the forecast gets, meaning the less reliable it gets. That's really counterintuitive when it comes to science, but it is what it is. So let's take a look at the three-dimensional atmosphere in the next slide. This is the one that's this is, your eyes can glaze over. The bottom axis, the x-axis, is the rate of temperature change predicted in degrees Celsius per decade. And on the left-hand side is altitude, starting at the surface and then going up to about 60,000 feet. The solid black line is the average of all the colored spaghetti. And the solid lines on the left are the weather balloon, satellite, and reanalysis data. And you can see that with one exception, all the colored spaghetti is way to the right. In certain levels of the atmosphere, believe it or not, the models are predicting 7 times. I didn't say 0.7 of a degree. I said 7 times more warming than is being observed. Why is this so important? Because the world's agricultural system depends upon how much moisture gets in the air and falls in the mid-latitude. And almost all of that moisture originates over the tropical ocean. The greater the temperature contrast between the surface and the upper air, the more precipitation is lofted, more moisture is lofted skyward and transported away from the tropics to fall on the world's agricultural mid-latitudes. 90%, for example, of the rain that falls on American agriculture east of the Rocky Mountains originates over the tropical ocean. It is exceedingly important. And so if you get that wrong by having the vertical temperature stratification of the tropics wrong, which is very obviously wrong here, you're going to get any forecast for future agriculture wrong. Any headline that you read that says global warming is reducing or will reduce or has reduced global agricultural productivity, we will see in a couple of minutes is just pure bunk. And I choose my words carefully. Let's have a look at the next image. Okay. All the time we hear, oh, the weather's getting worse. Hurricanes are getting worse. Storms are getting worse. Floods are getting worse. Well, here's reality. This is work by Ryan Maui, PhD in meteorology from Florida State University, very prestigious program. And what Maui did was he looked at all the satellite data for global hurricane coverage, which becomes global in the early 1970s. You're not going to miss a hurricane looking at global satellite data, and you can tell how strong they are by certain characteristics of the satellite image. He measured something called the accumulated cyclone energy index, which is basically the destructive power, if you will, of tropical cyclones around the world. That's the top graph, top line. The bottom line is the southern hemisphere, and the difference between the two is the northern hemisphere. The point is this: you can't see any change in this. There is no trend in the destructiveness of hurricanes integrated around the entire planet. That is just nonsense when you hear it. And the next slide, let's take a look at tornadoes. You know, the United States has more tornadoes per capita or per square mile or whatever than any place on Earth. And yes, you could read in the newspaper, oh my God, the number of tornadoes is increasing dramatically. Well, yeah, it is, because the country was eventually covered by these Doppler radars, which see these little weak tornado-like signatures in thunderstorms, prompt a tornado warning. There might be an F0, which is like a nothing tornado come out of them, or an F1, which might cause some damage, might knock over a couple branches or something like that. But no, it's the big ones, the F3, 4, and 5, the severe to extremely destructive tornadoes that we're interested in. And you don't need a radar to see them. Everybody notices them when they go by. And if you take a look at the data here, you could actually draw a line through that data and it would be pointing downward, not upward. I don't choose to do that because I don't think there's very much significance to that in this data. But the bottom line, the sure line, is it's certainly not going up. And anybody who says that it's going up is repeating one of my favorite words today, bunk. Now, let's take a look at how the country that has more tornadoes than anybody else adapts to tornadoes. The next image shows the number of deaths per million, I believe, or deaths per million from tornadoes going back to 1875. And you can see what a horror show tornadoes were before there was radar, before there was mass communication. And now, beginning around 1960 or so, when the first radars went out, and we have to credit David Atlas from the University of Chicago for testifying in front of Congress after an extremely destructive series of tornadoes in the early 1950s, that if we put out these radar sets, we'd be able to see them and we'd be able to warn people, and the number of deaths would drop dramatically. That is precisely what happened. What you're looking at is something called adaptation. Adaptation, in this case, to the most powerful intense cyclones on Earth, which are tornadoes, and in the country that gets the most of them. It's completely adapted to, yes, occasionally one will get loose in a large urban area or something like that and cause problems, but really it's a remarkable story of adaptation. Let's have a look at the next image, if we could, and talk a little bit about the future. Well, I think we can get this up here pretty quickly, I'm hoping. Let's just review what we've said now. The models have the wrong input. They're running too hot. And the next thing we're going to do is we're going to create a world which is a much better world. Let's have the next image. That's death. There we go. Aha! Corn yields in the United States, beginning around 1930 with the adoption of hybrid corn more universally, corn yields started to go up, and they've been going up and up and up and up ever since. Those stories about yields are dropping, they're just wrong. And it applies to all major crops. It's not just because of varieties, it's because of using more and more fertilizer, better tillage practices, weed control, pest control, all good things like that. Crop yields just continue to go up, and there's no evidence that they're not going to do that. If we take a look at it globally, which is in the next image, what you see, this is global crop production through, it's supposed to be through 2017. Anyway, it keeps on going up. In fact, if you look closely at this chart, this is not a linear increase, it's an exponential increase. Crop production is going up exponentially, average around the world. This is completely opposite from what Malthus said. Malthus said crop production will go up linearly while population will go up exponentially, and therefore we're all going to starve. And, this sort of is the grandfather idea for what I would call the pervasive pessimism that populates universities and science research on the future. It's just not grounded in anything close to reality. In fact, it's not just crops. It's the whole planet that's getting greener. And that shows in the next image. This is a paper that's 5 years old now, but it was the definitive paper at the time, and I see anything that has changed what's in this paper. This is a measure of the planet's greenness. And when the colors go into the green, blue, and then pink areas, that's where the planet's really greening up dramatically. And every place on this map that has a dot on it, the changes are statistically significant. Now let's take a look at where the pinkest areas on the planet are. They're the ones that are just greening up like crazy. Well, in South America, it's where the tropical rainforest is. In Africa, it's where the tropical rainforest is. And in East Asia, it's where the tropical and oceanic tropical rainforests are. In other words, the ecosystem that everyone was so concerned about, the tropical rainforest, the great reservoir of biodiversity on the planet, mistakenly called the lungs of the earth, by the way. That's not where the oxygen comes from. It comes much more from the plankton in the ocean, but what is this talk for but to destroy a few myths? Anyway, what we are really concerned about is getting greener and greener and greener. So, Zhu et al. Did what they called a factor analysis to try and explain the causes of this greenness. And that's in the next image. And what you will see, causes of greening. Number one cause is the increase in carbon dioxide itself. CO2 is plant food. It's well known that people who run commercial greenhouses increase the carbon dioxide concentration from the ambient 400 parts per million to a couple thousand parts per million, and the plants just take off naturally. That's causing 70% of the observed planetary greening. Nitrogen deposition, which is blow off from agricultural fertilizer, as well as from some emissions that occur in the combustion of coal, responsible for 9% of the increase in greening. And climate change itself is responsible for 8%. Now, how can that be? Well, if you looked at the map that we showed in the previous image, you will see large changes in greenness, excuse me, over the high latitudes of the northern hemisphere. That's because the growing season is increasing. What climate change does, and I published a paper on this, 20 years ago, it warms up the nights and the winters and the coldest air much more than it warms up the days and the summers and the hottest air. And it is, of course, at the end of winter that there's the last frost, and in the fall, the first frost occurs. Those occur at night, and that's what defines the growing season. And what's happening is the growing season, particularly in the high latitudes, is getting longer and longer and longer. So it gets greener and greener. And then the fourth one on here is land cover change. That's an interesting one from the perspective of the United States. If you drive interstate highways in the eastern or southern United States, you'll notice that you're surrounded by a jungle. It didn't used to be that way. This used to be marginal farmland with a lot of the vegetation was cleared from, but then it got outcompeted by the better farmland to the west, and it reverts to its sort of natural forested state. And it kind of literally is a jungle out there. Most of that land cover change in increasing greenness is occurring in the mid-latitudes of the northern hemisphere, especially in the United States and Canada. So the total human contribution to greenness is 91%. If we weren't on this planet, if we didn't run our societies the way that we do, we wouldn't have this greening planet. We wouldn't have all the increase in agricultural production that we see. We'd have some of it, of course, but a good portion of it is also due to carbon dioxide going into the air. And we probably wouldn't have models that have the wrong input. So just to summarize what we're talking about here, the computer models are fed the wrong increases in carbon dioxide. The models themselves run too hot. Putting the wrong increase in carbon dioxide in them makes them run even hotter. And instead, what we've got is a planet that has a modest warming rate that's getting greener and greener and greener. I don't know what's not to like about this. I don't know why we have to stop this. And anyway, if we tried to stop it, we wouldn't have enough money to do it. So it's going to continue to happen, which is a good thing. And thanks for your time. Okay, I have no sound coming in on my side.
Sorry, forgot to unmute.
There we
myself.
go.
Forgot to
unmute himself.
Yeah, forgot to unmute myself. Sorry about that. Thanks, Pat. Very informative. We have a few questions. The first question comes from Amazing World of Megan. Climate alarmists don't like it when you point out that the most stable, most fecund living conditions on the planet are warm climates like tropical rainforest and, of course, the temperate regions around the globe, and that there's barely any life at the poles.
Ain't it the truth? You know, it's really funny. When people take all the money they earned in their so-called productive life, they don't go buying property in Greenland. They move south and west in the United States. They move to where it's warmer.
Yeah, people don't retire
with their feet.
People don't retire to Minnesota. They retire to Tennessee or Florida. Yeah.
Yeah, and that's just the way of things. I mean, you know, I do recommend a trip to Greenland, by the way. It's a spectacular place, but you wouldn't want to live there.
So the second question we have, it's from someone named Greg Goodnight, or identifies himself as such. Has anyone back-checked the current versions of the model? So I guess that's CMIP6, using actual data from 88 to 20 to see if they could predict the temperature profile, saying that this might segregate out assumption issues versus model problems.
Well, yeah, they did. In fact, the two images that I showed of the CMIP5 and CMIP6 models are comparing the observations back to 1980 to what the models say, and you can see that they're just simply way too warm. How do you separate out the causes for that error? Well, again, we know one of them is that they have the wrong CO2 input. They're putting too much carbon dioxide in. And number two, the models themselves are just too sensitive to changes in carbon dioxide. There is a figure called the equilibrium climate sensitivity, the ECS. It's a metric that is a forecast of how much warming you would get for doubling atmospheric carbon dioxide and just leaving it at that doubling point. The CMIP5 models have an average sensitivity of 3.2 degrees Celsius for doubling CO2. The CMIP6 models are up to 4 degrees Celsius. And if you do the other thing, which is you generate a model not based upon physics that you don't understand, and we don't know the answers to all the physical things that go into these climate models. But if you generate them based upon observed temperature changes and observed changes in radiation with the changes that are being accrued in the atmosphere, you get equilibrium climate sensitivities of about 1.5 degrees Celsius. And in fact, that Russian model, the one that works so well, has about 1.5 degrees of warming in the 21st century. Hey, you know what? That's the aspirational target for the Paris Climate Agreement. The Russian model says we've already got it. So why are we bothering to pressure people to do more and more expensive stuff when you're never going to get to that disaster point in the foreseeable future.
Yeah. So, Pat, before I ask the next question, I want to give a general comment for the audience, because they've had several people have asked the same questions. If you want the PowerPoints, you can contact Jim or myself, and we can send those out. And yes, this will be up on YouTube. As soon as this closes out, it's on YouTube, and it will stay there, as long as YouTube is functioning and hasn't sanctioned us for some reason.
Oh, we'll probably
that could happen.
I wouldn't be surprised.
But otherwise, it's up there on the Heartland's YouTube page. So one question, and this is my own question. I looked at your graphics on the deaths per million, and what was interesting, these deaths from tornadoes, what was interesting to me is not only have they fallen dramatically over the past century and a half, but they've done so despite the fact that we've added hundreds of millions of people to the United States that, would potentially be affected by tornadoes.
Well, yeah.
And we've concentrated these people. I mean, used to, if a tornado struck, it was killing people largely on farms. I suspect it's still doing so, but we've got fewer people on farms than ever before. So it's sort of amazing.
Well, one of the things that's interesting along the lines of what you're talking about, we often hear this old saw that, property damages are increasing and it's a result of the weather getting worse. Well, it's not. Roger Pilkey out at University of Colorado Jr. has done a lot of work on this, and it's not that the weather's getting worse at all. It's that more people have more stuff to get hit by the weather. Think again of where people go when they can live where they want to. They tend to go south, and they tend to go to coastal regions. And in the United States, that means they're going to put all their hard-earned money on a house built on a hurricane-prone beach. One of these days, a hurricane's going to come and knock it down. It's going to cost a lot of money. In this country, the taxpayers help you rebuild that house. And a great country, or what? Anyway, so you have more stuff that's in the way of weather. You don't have more weather that gets the same amount of stuff. Well,
I do not see further questions, and I have no further. Well, now we have a new one. We have one that just popped up. It's from Rolf Wrights. I hope I pronounced that correctly. It says, warming makes water evaporate and makes clouds, which reflect sunlight. Why do models not account for this cooling effect?
Well, they sort of do, and they sort of don't. Different clouds, clouds being masses of water, are also essentially concentrated greenhouse gas. Water vapor is much more abundant in the atmosphere than CO2. Low clouds and cumulus clouds, they definitely absorb a heck of a lot of radiation and then doesn't not get down to the surface. Just imagine what it's like, on a cloudy day in the summer as opposed to a sunny day. The differences are dramatic. But higher level clouds, ice crystal clouds, cirrus clouds, they actually trap less radiation, and they are net warmers. The net effect of clouds, though, Rolf, you're right, is to exert a slight net cooling on the atmosphere. And I'm not so sure those climate models have got that right. You know why? Most of them resolve at best 1 degree latitude by 1 degree longitude. I think most of them are still around 2.5 by 5 degrees. So every time there's a cloud in the model, it could be hundreds of miles across. Every time there's rain, it's a thunderstorm that occupies 2.5 by 5 degrees latitude longitude. That's just way too big. And so you get over predictions and all kinds of instabilities. And, the climate modelers keep telling us if we'll just get them more and more powerful computers, they'll get it right. I think if we give them more and more powerful computers, they will have more precision to be wrong.
Well, in fact, of course, That's precisely what's happened, right? They say the models are better than ever.
Yeah, right.
The CMP6, CMIP6 is supposed to be better than the previous generation 5, which was supposed to be better than the previous generation 4, which, going on back. And the problem is every time they run a new iteration, the climate model projections get worse.
Yes, that is one of the odd characteristics is the more money we throw at this, the less reliable the forecasts become. In fact, the CMIP6 models are so warm that even Science magazine and Science, I mean, come on, a lot of people don't know that Rush Holt, who's the president of the American Association for the Advancement of Science, which publishes Science magazine, was by many calculations the most liberal member of the House of Representatives for a long time. He came from New Jersey, and what does he become? He becomes the president of the AAAS. Oh, there's no interaction between science and politics in Washington at all, right?
Yeah. So Tom Bradley says, I would like to see these climate wackos trying to explain the warming period of 1,000 years ago. At the start of the 11th century, there's a major warming period that was so warm that Northern Europe, Northern Asia, and North America were growing crops that normally grow in summer in warmer southern regions. There was less than 1 billion people on the planet then, and there were no fossil fuels being burned whatsoever. The only fuel they had back then was wood, no coal, natural gas, etc. In addition, I might point out, this was around the time that the Vikings set forth westward from their frigid regions and settled on the sunny beaches of Greenland and set up their first permanent settlements. I've read some articles in Science that said that they then sort of advertise it, word of mouth advertising. Come to sunny Greenland, Vikings. We can set up new settlements here. And then within 300 years, they're abandoning their permanent settlements because the ice.
Yeah, but I mean, it's amazing some of the buildings they put there.
Yeah.
There are remnants of cathedrals in southern Greenland. Yeah. It's really it's the climate there is very sensitive to changes, and that's another thing that I think, now that you got me going on Greenland, the big fear that climate change, warming raises is melting of the ice on Greenland. Because if you melted all the ice off of Greenland, you'd raise sea level by about 22 feet or something like that. Well, we've already run this experiment. It was run about 118,000 years ago. People obviously weren't around to run it. But at the beginning of the last interglacial period, not the current one, it was much warmer in the summer in Greenland than it is now. In fact, ice core records indicate that it was about 6 to 8 degrees Celsius warmer in the summer than it is now. That's a huge amount. And we can see how much ice was lost 118 to 125,000 years ago. It looks like Greenland might have lost about 30% of its ice over a 6,000-year period. That's 6,000 years. We can't make it that warm for 500 years. 6,000 years and only lost 30% of its ice. Years about Greenland losing its ice and washing everybody away in some sort of biblical deluge are just that. They're just fears.
Well, and of course, the assumption is that we won't adapt to rising seas at whatever rate they rise at
That's
whatever.
Correct, which is crazy.
We've already adapted. Boston has more landmass than it had when we settled because they've dumped all this dredge material into the bays, and so it's bigger now. The Dutch have learned how to.
Oh, sure.
The Netherlands have learned how to keep the water out. Not recently.
You know why they learned?
Not recently, but for hundreds of years now.
The reason that they became so good at it,
yeah.
And I can remember this from when I was a kid. There was a huge flood in the Netherlands in 1953, and tremendous number of deaths. And they said, okay, we're either going to have to leave or we're going to have to adapt. And they built these tremendous seawalls. Much of the Netherlands is as you know, underwater. Or below sea level, rather, as is for also New Orleans in the United States. And that's an example of adaptation to sea level rise. And then it's going to happen. Sea level just doesn't go up all at once. And another thing is, people get their homes knocked down enough times on a hurricane-prone beach. Maybe some of the zoning authorities might say, well, if you really got knocked down by a hurricane and it looks like you're going to get knocked down again, you can build your house there, but we're sure as heck not going to help you with insurance on it.
Yeah, I mean, Barack Obama was so worried about rising sea levels, and he warned about them multiple times during his presidency.
And he just had to cancel a party on Martha's Vineyard.
Yeah, that the house he built was on a barrier island less than a foot above sea level rise. So, I take it what happened there is he probably way overinsured his house and is expecting to really cash in when it goes underwater.
Yeah, right.
So, speaking of houses on beaches, one gentleman, T.M. Wilmsey, I'm almost certain not to have pronounced that correctly, says it's interesting that they build square houses on the beach instead of round, which are more hurricane resilient.
That's a very interesting point, Mr. Wilmsey, I believe. Hurricane Michael, Category 5 hurricane that came ashore in North Florida a couple years ago, just wiped out areas, I think, a little bit east of Panama City. And there's this one home that's standing and looks undamaged. Well, it was built to be hurricane proof. If you want to do it, you can do it within reason, of course. Some places don't build them that way. When Hurricane Andrew roared through South Miami and Homestead, I think it was 1991 or 1992, there were whole swatches of neighborhoods that were just completely destroyed. And then a few homes were standing. And it turns out that those homes were actually built to specs. And a lot of the builders there were kind of cheating and not putting in the right braces between the roofs and the walls, and everything was getting knocked down. But the correct design actually could survive it.
Well, we've had terrible hurricanes. Texas is known for being struck by hurricanes. Galveston, Corpus Christi, Padre Island. Stone structures do better against hurricanes than wood structures.
Well, here's an example.
The Bishop's Palace lasted through multiple hurricanes, but you know what they've done in Galveston?
Yeah, they raised the city.
Well, they raised the city, but they also after the last really bad hurricane about it's more than a decade ago now that struck.
The worst hurricane in Galveston was 1900.
Well, I know that, but of the recent hurricanes, the most recent one that really
Ike.
struck and hit hard, Ike, maybe 10 years ago or more.
Yeah, it was Hurricane Ike.
They actually hired Amish builders. They shipped them down from Pennsylvania Dutch country to rebuild homes on the beach because the old techniques built in flexibility in the structure.
Yep.
And they found that they withstand hurricanes better than modern structures that are stiffer. Now, Jimbo.
Well, that's adaptation.
Yeah, that's of course it is. So Jimbo the Coatsy, or Coastie, sorry. He asked, how do current conditions compare to medieval warming period?
If we talk about the warming period before the Little Ice Age, I suspect that current global temperatures are pretty much in the range of that. In other words, we're not at any place that's uncharted territory, to say the least. And current global temperatures are nowhere close to what they were at the end of the most recent ice age. It was a couple degrees warmer for several thousand years. Oddly enough, climate textbooks, when I started in this field, referred to that period of about maybe 8,000 to 10,000 years ago as the climatic optimum, because it was warmer and everybody thought that was really, really great. And then it became the climate horror show. If we warm it up 2 degrees, oh my God, we're all going to die. Well, we are all going to die, but we're not going to die from that.
Yeah, that's the old saying. There's one thing true that's about life. No one's getting out of here alive. So Cuba Blue asked, why is there an old Roman port and foreshore located 20 kilometers inland, close to where I live in the UK? Did the Romans build useless ports for the hell of it?
Probably not. I don't know about this one, but sea level changes. What can I say?
It's not. Yeah, it's not just the Roman port. There are places along the coast of Greece and Egypt and Rome. What is now modern day Italy, that are far, far, far inland from where the old ocean line went, and it shrank, and now it's coming back.
Well, yeah, and also I believe that the library in Alexandria is under the surface of the ocean right now. So,
well, yeah, what wasn't burnt to the ground? Yeah,
yeah.
Right. Let's see. T.M. Wilmsey asked a second question. He says, I know it's old news, but there doesn't seem to be much talk of the effect of the solar cycle. And I guess he's asking what your thoughts on that are.
Well, there obviously, I mean, it's as obvious as the difference between day and night. The sun warms the earth. Generally speaking, though, the changes in solar irradiance aren't enough to drive a lot of temperature change, but they can drive some. It's no coincidence that the depths of the Little Ice Age, which occurred in the 17th century, were accompanied by a period of 50 years where there were no sunspots. And it's just because we couldn't observe them. No, we could observe them. And this period, which is called the Maunder minimum, is very real. Turns out sunspots actually make it warmer than a sun without spots on them. And so when we didn't have any, it got pretty darn cold. And that was, when the time was that we had the winter fairs on the Thames River in London. You couldn't do that today. It'd sink. So, yeah, it was cold enough to freeze the Thames pretty much every winter.
So, Amazing World of Megan asked, she said, I asked my ecology professor about volcanoes causing extreme cooling effects because she was talking about the opposite. She said she'd heard about it, but then she continued talking about heating. What's going on with a
big volcano that has to inject into the stratosphere, preferably into the tropics, like Mount Pinatubo in 1992, or Mount Agung in 1963. Yeah, they cool the surface temperature because they put particulates in the stratosphere. It takes them a couple of years to eventually settle out, and that blocks the incoming solar radiation. We have had very little volcanic activity, by the way, since Pinatubo. There's been nothing super major go off, and so there's no countering effects of warming from volcanoes. And yet, you got to remember that how many stories did we read beginning around the year 2010 about the pause in global warming? The surface temperature just stopped warming in the late 1990s, and it didn't do anything until about early 2014, until we changed the data, which is what happened in 2015. Just in time for the UN conference for the Paris Agreement, all of a sudden the temperature pause in warming disappeared. I could tell you what was done, but it'd take too much time. It was kind of a travesty.
Well, I mean, and going back farther, let's go to Krakatoa. In the United States, they talked about the year without. Yeah, well, they also talked about the year without a summer because
that's from Mount Tambora in 1816.
Oh, I thought Krakatoa was that as well.
Tambora was
even bigger than Krakatoa. Yeah. No, but they both had worldwide effects.
Oh, sure.
They both had significant cooling, and I would wager, if you go back and look at newspapers at the time, they were warning of serious climate change from global cooling, and what can we do about it?
Oh yeah, one of the pioneer books in the whole area of climate change was published, I think, around 1967, called "Times of Feast, Times of Famine: Climate Since the Year 1000" by Emmanuel Audrey. It's still worth a look. He looked at the grape harvest dates, and he's got pictures of glaciers coming down the European mountains and people going to church praying that the glacier is not going to hit the town this year.
Right.
And
Yeah, no,
their prayers were answered. You know what happened? It warmed up.
Old woodcut pictures you can find in old books of the glaciers coming down in the chateaus and villages. And, you want to talk about something scary. That's scary. Glaciers coming down and scraping off all of Montreal when the next ice age comes. That's
well, I believe where you're sitting right now had about 5,000 feet of ice over it about 30,000 years ago, didn't it?
Well, now that may be in Chicago. I think we were in inland sea. I'm in Dallas.
Oh, okay.
I think we were part of an inland sea.
Yeah, well, there's no such thing as climate change.
So, another question from Amazing World of Megan Quistive. She says, talking about polar bears, she also her teacher also didn't like it that I asked if a polar bear population is 25,000.
Right.
And they were only 12,000 before. She said yes to both.
What do you mean?
I'm not
yes,
sure.
It is 25,000?
Yeah, it's 25,000. She admits it to 25,000 now.
Right.
And B,
12 years ago.
12 years ago. She says yes to both. They haven't doubled in 12 years. That's not right.
No, but there are more of them than there were.
No, they've gone up significantly over the past, since the 60s. They've gone up.
And they seem to be very adaptable creatures.
Well, they are a subspecies of bear.
Yes.
But all bears are omnivores.
Yeah, if you cross a polar bear, you can cross a polar bear with an Alaskan brown bear, and you'll get cubs.
And so they do. They found some of them, which they blame on climate change, by the way. But the point is, they can and do interbreed, and even polar bears, though they have come to specialize on seals as easy meals, they're also known to scavenge on whales and walruses.
They'll eat anything.
They'll eat anything. And
just ask the citizens of Churchill, Manitoba.
Yeah.
And
so
it's onslaughts of polar bears every year. The city dump is apparently very popular.
Right. So Miss Wilmsey asks, she says, my understanding is tornadoes happen when the warmth of the oceans meet the cold of the plains. Wouldn't more warmth mean fewer tornadoes?
Actually, that's pretty close. One of the characteristics of greenhouse warming is that it should warm up the high latitudes and the poles more than it warms up the tropics. And it is the temperature contrast between the two that drives the jet stream. And in screwy places like North America, where there's a north-south mountain range interrupting the jet stream, it tends to cut off little whirls, which ultimately create upward motion, which creates tornadoes. So that actually gets weaker in a warmer world. So that is correct. And also, I think you probably should get weaker winter storms, though. Snowfall data is very, very screwy stuff. There's not a lot of trends in that you would. Places where you think you'd be seeing trends like the eastern U.S., you just don't see them.
I would think, and maybe I'm wrong here, but I have written in the past that it should also end up reducing hurricanes, and that's because hurricanes mostly form in the tropics, and they work on the gap between sea surface temperatures and the atmospheric temperatures, and the tropics aren't warming as fast as the poles, but sea surface temperatures have gone up some. So
they have.
They're sort of a heat pump, and it should disrupt the heat pump.
Well, the thing that I always, when discussing these things, I like to confront something called reality. We do have Ryan Maui's accumulated cyclone energy index for tropical cyclones around the planet, which I showed earlier on, and it shows nothing. Yes, by the way, if you look in the Atlantic basin, you will see a rise in hurricane activity beginning in the mid 1990s. It went on to about 2009 or so, something like that. And the government published a report 5 years later talking about this increase in hurricanes. They left out the years after 2009 because if you put that in, the whole relationship fell apart. I hate to say it, but that's unfortunately the way this is done now. A recent example that was in the news, if you were looking carefully, everybody knows that the 1930s had much more frequent extreme high temperatures than anything we've seen. And so the Environmental Protection Agency, in its latest global warming report, decided to start the extreme temperature index in 1945 or 1950, just to wipe out the embarrassing data. I mean, this makes 1984 look like a walk in the park when you're screwing around with geophysical data like that.
Well, Pat, we're coming up on an hour, and so I'm going to take two more questions, and then I'm going to let you go and sign off ourselves. Christine Landale, sorry, I said Lansdale. She asked, why are governments so stubbornly in denial of your scientific research results?
Because they like to push you around. If it's the old saying, politicians make their living by making up things to scare us to death so that we'll demand to be led to safety by them. That's an old adage that is unfortunately true. And you're up against a tremendous amount of money. I mean, I mentioned earlier on that the head of the AAAS, American Association for the Advancement of Science, was one of the furthest left members of Congress for a long time. They all like this big government stuff. And, if you go around saying, well, this issue is overblown, you're going to throw so many scientists out of the front cabin of the airplane that they're just going to be very, very unhappy. It's just the way it is.
Well, now that accounts for government, but we do have a question from Danton Rose, and asking how dishonest is the debate in academia among professors? Are college professors just spewing whatever is said regarding the news of climate change, or why? What happened to academic honesty and freedom?
Tenure. I was on faculty at University of Virginia for 30 years. And my line was not tenurable. I was promoted from assistant to full professor over the years and all that good stuff. But it struck me at the faculty meetings that tenure, which is supposed to promote free speech, is really like a forced group marriage between 30 people for life. And, in marriages, there are certain things you don't say because they might be held against you. And they might come up 10 or 15 years later. You said that to me at that faculty meeting. You're full of beans. So it actually restricts freedom of speech and thought. I was not well liked. I can tell you that and I used to see notes on the chairman's desk, we've got to do something about him. We've got to do something what he's writing. It's just a terrible place. I'm glad to not be there. Yeah. I could never get a degree now at any undergraduate institution that wasn't Grove City or Hillsdale.
Well, that's what it comes down to, right? Is that, look, if you're a young faculty member, you want tenure. And so you don't disagree with those that have it, that have liberal views. And if you're coming out of college and you want to get on a faculty, you can't. Not only have you been told this is the truth, but even if you have done your own research and actually disagree, you're not going to say that, because then you don't get hired in the first place.
Yep.
Once you've got tenure, it seems to me, if you spent your entire career saying one thing is the case, you can't suddenly come out and say something else, because
it's
undermines all your previous work.
If you say the emperor has no clothes, the emperor cuts off your funding. Yeah, so you're tenured now as an associate professor, but you're not going beyond that. So you have to keep on doing it. And it perpetuates the lie. There's an incredible thing that came out by a guy by the name of Eric Kaufman on the problems in academic freedom and tenure. I published a rather extensive piece on it. You can find it online, called The Death of the Academy. And it really foretells the death of the Academy. It's a remarkable book.
Well, the questions have been great. Your presentation was great. I want to thank Patrick Michael for participating in today's event and everyone in the audience for joining us. Now, I'm sure everyone watching this presentation came away better informed on the difference between alarmist claims of catastrophe and the climate reality than they were before they heard Dr. Pat Michael speak. Before you go, I want to remind you this event and every presentation we do in this series will remain available at Heartland's website for anyone who wants to review it or share them with friends who are unable to attend. We will be having the next one. Watch for Jim Lakely's notice. It should be in a couple of weeks. We haven't decided on the speaker, but we'll get that lined up soon. In addition, please be on the lookout for notice. Please, before signing off, I want to ask everyone to take the opportunity to encourage you once again to attend the 14th International Conference on Climate Change in person in Vegas this October. And go to Heartland's website and the Heartland Daily News website for the latest in environment, energy, and climate news. You might also check out, if you're not already reading it, my Climate Change Weekly newsletter. Finally, I'd like to encourage you to support the Heartland Institute year-round, and you can contact anyone, and they'll put you in contact with David Hoyt, Heartland's Executive Director of Development, and tell you how you can help us be more successful in our mission. Thanks to everyone. Take care. Bye.
Bye.